Hello, everybody. Um, my name is Jonas Jansen. I'm from the RWTH Aachen University, and I'm gonna tell you a bit about our findings, how to rapidly design and effectively operate a Ceph cluster. And yeah, we're gonna start with the resiliency you like to reach, and first important thing is to use multiple data centers. We are using 4 data centers, and important thing, if you have the ability to use multiple data centers, is you need dark fiber or some kind of high speed connectivity in between those data centers. Next thing is you need to take account of the appropriate crash hierarchy levels in your crash map when you design this first, because if you like to scale later, maybe you add rows or something in your data center, and it's hard to put it in at the later point of scaling. And also you should take account of the failure domains of your nodes. A good calculation point is one single node should never be more than 9% of your cluster capacity. But also think about the other things that can fail at once. Next thing is the efficiency. Of course, the most important thing when it comes to efficiency is use of erasure coding. If you have not that latency critical application like most S3 storage, but you have to take into account you cannot use erasure coding for all proposals like the index pool of your S3 storage. Also important thing, Bluestore is much more I/O efficient than Filestore. And of course you have to take into account the cost efficiency. So you can think about what kind of parts of your nodes really need to be redundant. Do we really need to have redundant OS disks? Do we really need to have redundant network ports or PSUs? Now we are looking at the compliance and workload reduction. First of all, you should have a configuration management tool like Ansible. I think Ceph Ansible is a great project you can start off. And you should also use your configuration management tool to automate your operating system updates. So you can do them regularly and in a fast manner. Also, everyone should have a good test environment, especially for proposals like updates or changes in your infrastructure as code. And of course, you need to keep your test environment up to date so it behaves the same like your production environment. I already mentioned the infrastructure as code, like the Ansible playbooks and configuration. I highly recommend to use a version control system like Git to keep them versioned, so you can always see who has changed and when has been changed what, and what may have caused this behavior of our environment, of your environment. And last thing for compliance is, do not fix your node installations. Just reinstall them. Most time when you fix an operating system or something, it gets non-compliant. So do reinstall, have a clean start, and mostly this works. Coming to security, we recommend always to do an automatic patching. So this speeds up remediation of security flaws. And if you have your test environment patched on a regular schedule automatically, you can react really fast to deploy your security patches to your production environments. Next important thing about security is to split your gateway network from the public network of your cluster, because this way you can do a more restrictive firewalling to your gateways, and also if a gateway gets compromised, they're not that near to your cluster. Next thing is do security tests. We have great tools like the Mozila observatory, so you can test your configuration of your gateways. Most of us, I think, have a reverse proxy in front of them, like HA proxy. You can mess up a lot of your configuration in these tools. And also, there are situations where something goes wrong with your TLS certificates. So check them on a regular basis. They check if they are not expired, or maybe if they have changed. Most important thing about security is collect your logs and combine them. Collect especially from the gateways, combine them with network facilities, so you can have a complete view on all components that are included in the attack vector of a network attacker. And last, why I think we were fast in our design. It's because Ceph is ready for production if you pull it from the repositories. We set up Ceph as we set up every normal off-the-shelf storage software, and it worked great. Also, because Ceph is scalable, one can choose a medium size of setup in every means, and then you can have a look at what performance bottlenecks do you have, and you can scale up at these points. Maybe you need to add CPU or RAM or something like this. And most default configurations of Cephs are great, and you can use them. Okay, and that's all from me. So thank you for your attention, and if you got questions, you can ask them afterwards or send me an email. Thank you.